So 4F question 3, a girl wishes to swim across a river which is 60 meters wide, 60 meters. The river flows with a speed q. So the river flows with a speed of q meters per second, parallel to straight banks, and the girl swims at a speed of p relative to the water. So that's how we're going in this direction with a speed of p meters per second. In crossing as quickly as possible, okay, well, she's going to cross as quickly as possible. She's going to go with the flow of the river, so she's going to go this way. She takes 100 seconds and she's carried 45 meters downstream. So we can use this, we should be able to use distance, speed, and time here to get P and Q. So she's going at a speed of P meters per second, and she crosses 60 meters. So distance divided by speed is equal to time. And this includes the flow of the river, or the speed at which she's swimming in relation to the river. It says that P is the speed relative to the water. So that would give P to be 6/10, which is 0.6. And then crossing as quickly as possible, she takes 100 seconds and she's carried 45 meters downstream. So that would be my distance, my speed, and my time. I'm looking for the speeds. So what do I have here? I have the distance. She's carried 45 meters. We don't know what Q is, but it takes 100 seconds to get there. So Q is 45/100, which is 0.45. So for the second part, let's have a look here. How long will it take her to swim back to the original starting point? So if we imagine she's here, she has to get back to here, which is 45 meters upstream because she landed downstream. So if we just change our diagram around, so let's say she's here, she has to go and finish 45 meters upstream. So she's going to need to go out in this direction a little bit. So what have we got? We have the width of the river. We have our flow of 0.45 T. Was it 0.45? It was for Q going that way, and this way here 0.6 T. Okay, so we need to get some variables into this triangle to find out T and get T then back into our sine rule. So let's just take this triangle out to begin with, the right angle triangle. 60, 45. Getting this angle here will enable me to get that angle with my straight line. So the tan of A is equal to 60/45, which is 4/3. The inverse tan of 4/3, 53.13 degrees. Yeah, it's our common one, 53.13 degrees. So B is equal to 180 minus 53.13 degrees, which is, what is that, 127.87, 126.87 degrees. So that gives me one angle inside that triangle. So I label this one C. That should help me, shouldn't it? So just take that triangle out. It looks something like this. So I have C, I have B, I have 0.45 T and 0.6 T. So 0.6 T over the sine of B, 126.87, is equal to 0.45 T over the sine of C. So 0.45, I'll divide by T. Sine 126.87 is going to be 0.6 sine C. So just bring my 0.6 underneath. So that will give me sine C to be, give me 0.5999999, so it's probably 0.6 exactly with the rounding of the 126.87. 0.6. Okay. So the inverse sine of 0.6 gives me C to be 50 something, is it 50? No, 36.87. Or 180 minus 36.87. It's going to give me 143.13. Okay, so I have two values for angle C. Well, this one can't, angle B is definitely consistent. It's 126, so these two can't work, definitely. They add up to more than 180. So to get my angle, my third angle, so I can use my T. What have I have? A, B, C, and D. So D is equal to 180 minus B, 126.87 minus C, 36.87. So angle D is going to be 16.26 degrees. So now I can say the sine of that, the sine of so do I have that distance? I do have that distance as well, don't I? I had it earlier from the width of the river was 60, that was 45, and we got 75 in here. So the sine of 16.26 over 75 is equal to the sine, I'll use the 126, sine of 126.87 over 0.6t. So cross multiplying, 75 sine 126.87 is equal to 0.6t by the sine of 16.26. So divide across by the 0.6 sine 16.26. Should give us t. That gives me t to be 357. She's swimming back into the current 0.146, so 0.15 seconds. What do they ask for here? Nearest second to the nearest second. So 357 seconds is the answer to this one.